Hello, welcome to New Planet School. In this video, I'm going to talk about radians and degrees, but more specifically, how do we measure angles and why do we have these different units? So let's think about that for a second as we get started. In general, how is it that we measure things and what are some of the issues that come up? So let's think about time and distance, for example. In the case of time, everybody knows how to measure time. We have nice units like seconds, minutes, days, years, and so forth. And we use this very intuitively, and there's not really a problem. But what it makes you realize is that there are different ways, different units of measuring time, and you can go back and forth between them. Like you can specify something in minutes, or you can specify something in seconds. And because we know that there are 60 seconds in a minute, that we can always convert back and forth. Just like we have 24 hours in a day, and we can't really say how many days there are in a month because it changes. Years are a little bit tricky. Sometimes a year is defined as the time it takes a planet to go around a star. Well, that depends on the planet and the star. For us, some people will say that's 365 days, but actually if you look at it in more detail, it's 365.25, and then there's even something called a leap second where they correct it every once in a while. And so even though we sort of have a sense for this, it can be complicated. There's seemingly arbitrary numbers for the conversions, and there's little tricks in there, but we know intuitively how to handle this. The same thing goes for measuring distance. We have lots of different ways of measuring distance, from the micron or shorter all the way up to the light year. And again, we know how to convert. And again, there's a lot of arbitrary numbers that come in. 12 inches to a foot, 3 feet in a yard. There's no consistency here. How many yards are there in a meter? There's some number. And so there's these little inconsistencies and sort of arbitrary numbers that come in. But we know that whatever we want to do, we can measure in any of these units and be able to go back and forth if we know these conversions. And what we typically do in both cases for time and distance is we pick the unit that has some advantage to us. Like it's easier to say my house is this many miles to the grocery store because that means more than if I specified that in, say, parsecs or centimeters. So those are sort of the ideas, is that there are different ways of measuring things. There's often arbitrary conversions between them, but if you know what they are, you just convert back and forth. And typically you pick one that's convenient to you. So let's see how those ideas that you already know go over to measuring angle. Because when you're doing trigonometry or some practical thing like architecture or robotics or anything, you've got to be able to specify and use angles. You have to have a way of measuring it. So how do you measure angle? Well, there's many units, just like there were for time and for distance. There's many units for measuring angle. Now, if they'd come and asked me, how would you measure angle? I would have used a unit called the turn, which you may not even have heard of, but I kind of like it. But there are other definitions that people have come up with because, in fact, they didn't ask me what we should measure angle in. So people over the years and decades and centuries made up a bunch of other units like degrees. And degrees in a circle goes up to 360 degrees, and you have a little circle there to specify that. There's other units like gradians, and to make it complicated, there's 3 different ways of saying gradians written here. And there's a unit called a mil used in the American military. There's also radians, which is one that we're very interested in, and so forth. So there's a lot of different ways of measuring angle, just like there are different ways of measuring time and length and anything else. It can even be a little bit more complicated because angle can also be related to other concepts like incline or slope. And gradient is another concept that comes up a lot in math, like in calculus, the rise, the pitch. And of course, these things can also be measured in terms of their angle, which then uses all of these different possible units. So it can all be fairly confusing, but try to keep in your mind the whole goal here is to specify a unit that is convenient for you to measure some particular angle. But it is definitely confusing. Like here's an example. Take this one right here, the grade. What would be 1/100th of a grade? That would be a centigrade, just like a centimeter is 1/100th of a meter. Problem is, a centigrade is also a unit that people have used to measure temperature. And so because of that, that's why we now measure temperature often in something called Celsius instead of centigrade. It is very confusing, but just keep in mind what the goal is. We're trying to measure angle with a unit that's very reasonable. Okay, so let's focus on 3 of these. Okay, now what we're going to do is we're going to define the unit based on what the angle is when you get all the way around. So let's take my favorite, which is the turn. If you have a turn, here's what it looks like. You start measuring an angle, and as you go around some angle, when you get all the way around in a circle, the value of the length of that angle, or the angle, is 1. That's very simple. It's very intuitive. You start at 0, angle, and when you're all the way around, you get to 1. What could be more perfect? That's why I kind of like that one. Now, degrees, of course, is a very good one too. That's the one that we usually use when we're speaking to each other, and we usually put a little circle up here to make it clear that we're talking about degrees and not some other quantity. And so how does this work? You have an angle, you start to measure it, you start at 0, you go around to measure that angle, and when you get all the way around, you eventually get to 360 degrees, and that's what that means. And so every angle in between then is measured as some fraction of 1 if you happen to be using units of turns, or a fraction of 360 degrees if you're using degrees. Now, the third one we'll look at is radians, sometimes just written as some multiple of pi, written different ways. You could actually write radians here, or sometimes people will just put RAD period to abbreviate it. Same idea. I'm going to measure the angle, and as I go all the way around, when I get all the way around, I reach an angle of 2 pi, starting with 0. And so that's the radian. Now, I also mentioned earlier the gradient, so let me throw in a fourth example, which is the gradient. In the gradient, if you go all the way around, you get to a value of 400. That's the gradient. That's another nice unit. The reason this one might seem slightly intuitive to you is we often look at 90-degree angles. If we have a 90-degree angle, we say that angle is called 90 degrees. Well, 90, why 90? Well, we like to use numbers that are divisible by 10, like 10 and 100 and 1,000. So instead, if we define this to be 100 of something, that would be a gradient. So this is 90 degrees or 100 gradients. That's another unit that you see. I mention that because it's sometimes on calculators, but it's not used very much. So you can see that these all have the same goal. They're just measuring angle, and there's different reasons for using these. The turn I like because it makes kind of sense. 0 to 1. That's kind of very intuitive. 360 degrees, why do we have 360 degrees? Turns out probably nobody knows where this number actually came from. There's different hypotheses that maybe the Babylonians were using a base 60 number system, and so this is a multiple of 60. Other people have hypothesized that it's roughly the number of days in a year, and maybe that's actually related to using a base 60 and so forth. But in the end, it doesn't really matter. You could actually make up your own unit system if you want to, and you could use that. Okay, so where are these used? So you're going to come across degrees and radians. So let's think about why that happens. In everyday life, and of course in homework problems because people want you to understand it, in everyday life we almost always use degrees. And so you have to understand how to think and work in degrees, because that's how we talk to each other. We always specify that, a right angle is 90 degrees. And if you went to the store and bought a protractor like this, it's almost certainly going to be in degrees. That's just the way we work in everyday life. Just got to get used to it. So the question arises, why would we do anything else? Why would we use radians, and where would we use radians? So typically radians come up in science, engineering, math, and other related fields, music, and so forth. And the reason for that I will talk about in a bit, but the basic idea is that if you're taking classes in science, engineering, and math, you really need to get used to radians. And as I said, I'll show you why it's much more convenient to use radians in science, engineering, and math. I use radians all the time. I almost never use degrees unless I'm talking to somebody. But what's important is that you know both, because when we talk about angles, we think in terms of degrees, but when we do math problems, we always do it in radians. So you need to know how to do the conversion to go back and forth. And if you understand the conversion, you understand that both of them are just two different ways of measuring the same thing, just like feet and inches, there's no problem at all. Okay, so why ever use radians? Let's look at that for a minute. The reason is simplicity. As I said earlier, when you measure, for example, the distance from my house to the grocery store in miles, it's just simpler because I can say 2. I don't have to say 0.00358, whatever's. It's just very simple to do that way. So we always use the simplest form. So why is this simple? Okay, here is where radians come from and why they lead to simplicity. So consider a circle. And that circle, in fact, all circles that have a radius r will have a circumference given by this formula right here, every single circle. So if you get a tape measure and you measure the circumference all the way around this circle, and then you take that same tape measure and measure the radius and divide those, you will get 2 pi every single time. In fact, you can consider this to be the definition of pi. It's one possible way of defining it. Now, one of the interesting things is we could have made a different choice. Since this factor 2 pi comes up here and in many other places, we might have made a choice to call this tau or some other quantity. We don't have to call it 2 times something. We could have called it just tau. But historically, we call it 2 pi r, and that's a sense, as I said, the definition of pi. Okay, so this is something you can just go measure. This is not some arbitrary choice here. This is something you literally can take a tape measure and go measure this. So that kind of fixes what pi is. Now let's look at arc length. Imagine that we want to measure the arc length of these 3 circles, different parts of it. And each of them will have a radius r. And we want to know how to specify some length. Like let's just take the arc length as I go halfway around. What is the arc length? Well, in general, measuring the length of a curve like this requires calculus, and it's pretty complicated to do that. But we don't want to use calculus here. So what can we do? Well, it's pretty obvious what we do. We know that the distance all the way around is 2 pi r. If this is halfway around, obviously, that arc length is pi r. Pretty simple. Let's suppose now I go a quarter of the way around. Okay, well, again, I don't want to use calculus, and I don't need to, because I know that's 1/4 of this, and it's 1/2 of this. So that must be pi over 2r. And I can continue doing that. I can go quarter of a way around, go here, and that would be pi over 4r. And so one of the things you notice when you see this pattern is that the arc length of a circle is given by some factor times r in every case, and that factor is proportional to how far I went around. If I went around half as far, it would be half the value. That prefactor would be half the value. And of course, halfway around this is half the angle. And so this prefactor is in fact related to the angle that I went through. This is half. This is half of that. So it suggests that I might be able to write a formula that looks like this for the arc length. And wouldn't that be nice if I had something this simple? This would be a nice formula for arc length. But all we know is it's proportional to the angle. We don't know that it's equal to the angle. There might actually be a little constant in here. We don't know that. So let's try to figure out whether or not I can actually use this formula for the arc length. Well, what do I know? I know that when I go all the way around, I have to get this equation over here. So let's try it. I can do S equals R times 2 pi. That is, if the max angle is 2 pi. In other words, I get this formula right here if I measure my angle in units such that when I go all the way around, I get to 2 pi. So wouldn't it be convenient to measure angle in units such that if I go all the way around, I get to 2 pi? If I do that, I don't need this constant right here, and I get this very simple formula. And that's what we're looking for, is simplicity. And those units, if I define those units are called radians. And boy, do they make things very, very simple. So that's why we use them, because the formulas written in radians have very, very simple forms. So let's get an intuitive idea of how big a radian is. Is it bigger than a degree? Is it smaller than a degree? Is it comparable to a degree? Let's think about that for a second. So let's look at this. If I have S equals R theta, because I'm measuring my angle in radians now, if I have that, suppose I have this circle with radius R, and I go through some angle, theta. This is also R over here, obviously. And I want to know, what is this angle if this is 1 radian? Is that a big angle? Is that a small angle? Let's find out. So let's write that down. S equals R theta. This is in radians. That's why it's so simple. And if I want to know how big that arc length is if theta is 1 radian. And that equals R. Therefore, if this is 1 radian, this arc length right here is also R. So that gives you a very intuitive sense for what the size of a radian is. And you can see it's quite a bit bigger than a degree. Because think about this. If I were measuring angle in degrees, say this is 90 degrees, 1 degree would have to be, a very small thing. That's probably even too big, where this is 90. So a degree and a radian are very different in size. 1 radian is many, 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 many degrees. And I'll show you how many it is when we do the conversion. Okay, now that simplicity doesn't stop there. As you get into other parts of math and you get into doing Taylor series, you get into calculus, what you'll find is all the formulas, if you measure this object in radians, has a very simple form. You have these powers, you have these numbers here, but there's not a bunch of pi's floating around, 360 degrees floating around. Very elegant, very simple. Same thing here. Very simple. D dx of sine x, the derivative of sine is cosine. This is from calculus. Derivative, very simple form. No pi's floating around, no 180 degree conversions floating around. Very elegant formulas. And so everything you do in math, engineering, science, and whatever, if you measure things in radians, all the formulas are simple, fewer factors, and what that means on practical level, you're going to make fewer mistakes. So try to use radians. All the formulas are simpler, and they make a lot more intuitive sense. And in this sense, even though I said earlier that I like the unit, the turn, in fact, in reality, the radian in mathematics is the natural unit to use, and that's why everybody uses it. Okay, so keep in mind, you can always go back and forth, and you will need to go back and forth from degrees to radians. So whatever unit you're in, make sure you know which unit you're using, and know that you can just go back and forth at any given time. use whichever one you want. They're all equivalent. If you want to write all those formulas in degrees, because you like degrees, go write down all the formulas in degrees and just use them. There's no problem doing that. They're going to be messy, but you can actually do whichever one you want. There's no funny business here. But just keep in mind that when you're working a problem or thinking about a problem, just be sure that you know what units you're in and why you're doing it so that you don't make mistakes. Like one common mistake is that people they'll be working in one unit system and they won't notice that their calculator is set in gradians or radians and degrees, and they'll work out a problem and get the wrong answer simply because they forgot that they have to work in degrees. It's like working a homework problem and it's assuming feet and you're plugging in inches. Obviously, you're not going to get the right answer. Okay, so how do you convert back and forth? This is the one thing that you need to know how to do to make it all very easy. So let me explain this in a way that you can easily remember it. Okay, so we remember that the units are defined as what the value is in that unit when you've gone all the way around the circle. Okay, and so 2 pi radians is the same as 360 degrees. That's the same angle. That's the angle going all the way around. So if you memorize that and that concept, it's very easy. So let's do first degrees to radians. So I have a problem. I have some number x degrees, and I want to know how many radians is that. So what you do is you simply write, well, I want to know how many radians. I'll call it y. So y radians is x degrees, and then I'm going to multiply that by something that's equal to 1 because I don't want to change it. And I know that 2 pi radians equals 360 degrees, so this is 1. So I can multiply by that, and then I get radians. And you can see that that's going to work out because the units will work out. And be sure to always check that the units work out. The degrees cancel the degrees, and I'm left with units of radians, which is what I want. So multiply by 1 and make sure that you get the right units. Very, very simple. You can't really mess it up. So if you're worried about is it 2 pi over 360 or 360 over 2 pi, it's very obvious. Only one of them will give you the right units. Sometimes you'll see this written as, I can cancel a 2, so sometimes you'll see this written as pi radians over 180 degrees. That's fine. You could write it that way as well. The reason I like to write it this way is because I have committed this to memory and this concept to memory, and so it's easier for me to think about this. But this is completely equivalent. So the other thing you can do is if you forget this formula, you can always figure out whether you have the right answer in the following way. I have y radians is x degrees times 2 pi radians over 360. So what I can do is say, well, what if I went all the way around? If I went all the way around, I'd have 360 degrees, and then I multiply by 1, and I have to have something that equals 1, which is 2 pi radians is equal to 360, and I know it has to be this way because I need the units to cancel. And then what do I get? The 360 cancels the 360, and I get 2 pi, and therefore 360 degrees equals 2 pi radians, and I've checked my formula. So you can use this as a check if you forget the formula. So in fact, if you work through this systematically, you'll probably find it actually very hard to forget this formula. It's pretty simple. Okay, now what if we wanted to go in the other direction? Now it's very easy. It's the same thing. I have some number of degrees I want to know, and that's equal to some number of radians times the conversion factor. This thing has to be equal to 1. Well, 360 degrees is equal to 2 pi radians. And it has to work this way because the radians have to cancel, and then I have to be left with units of degrees. So it works. And again, I can check it. What if I went, let's just do something else. What if I went halfway around? That would be equal to pi radians times 360 degrees divided by 2 pi radians. Radians cancel, pi's cancel. 360 divided by 2 is 180 degrees. And now I know that I go here. That's either 180 degrees if I'm measuring in degrees, or it's pi if I'm measuring in radians. And so it all checks out. So very easy to go back and forth between the two unit systems, just like you can go between feet and inches or whatever else, this is the way you go between the two main measurements of angle. Okay, so let's just go back to that plot that I showed earlier just to give you some intuition. So what I'm going to do here is I'm going to plot a line that goes around from the center. It's going to go around and it's going to measure angle, and I can measure it different ways, and let's just make sure that we get what we think we're going to get, and I'm going to do it in 4 different unit systems now. The top will be degrees and radians, and the bottom is gradians and turns. And you can see it's the same angle. I can just measure it in 4 different units, and in the end, when I get all the way around, you can see that I have 360 degrees, 6.28 is approximately 2 pi, and down here 400 gradians and 1 turn. Okay, so for practice, what you might want to think about is to take this to the next level, is to connect it with the rest of trigonometry and geometry. So one way to do that is to think about the unit circle and just make sure that you understand, if you have a unit circle and you have different points on there at different angles, that you can write for any of these points. I just chose these points randomly, but you can pick your own points. You might want to pick one here, you might want to pick one here, but pick some number of points and make sure that you can specify that angle in different unit systems. Here I'm specifying this in radians here. It's always a guess that there's a factor of pi showing. That's a clue that it's in radians. And here I can specify it also in degrees, but what would that be in turns and what would that be in gradians, for example? And then make sure that you can do the conversion. So let's try it. Pi over 6, let's just check it, equals 30. This is radians and this is degrees. I need to multiply by 1. I need to multiply by 1 such that the units cancel. So I have to have the degrees in the bottom and the 2 pi radians in the top. And what happens? The degrees cancel. I can always cancel the zeros. 3 into 36 is what? 12. And then on top I have 2 pi radians. Can cancel a 2 on top and bottom, and I get pi over 6 radians, and it all checks out. So you can go through all of these and make sure they check out. It's a great way to make sure that you completely understand it. And then to connect it to trigonometry, see if you can connect those angles to the actual values of the points at those coordinates, and that'll help you then be able to connect all of that to the concepts of, what this distance is here and what this distance is here, and then you're on your way to understanding things like sine, cosine, tangent, and the rest of the trigonometric functions, and then all of it will make complete sense to you. Okay, and with that, that's all I have to say about degrees and radians. Hope to see you here soon.